having me today. I would just quickly share my screen, and I will also just wait. I just need to get. You cannot have the chat and the screen sharing at the same time. I would just post the link to the GitHub repo in case you don't have it. So now back to the screen sharing. So if you open the GitHub repo that I posted in the link in the chat, you will have access to this beautiful repository where you do have all the material at hand. So you have the slides here. You can click on it if you want to have the slides for yourself. I also provide you with the raw code in case you're interested. And we also have the code deployed. Once you click on it, you will be guided to a Netlify page that shows you the Markdown page in action. I will show you a few code demo on my screen. You can use, you can watch my screen to follow that. You can also use that site, like the website, to follow it. Or you can, like a third option, if you wish, you can also download the entire GitHub repository as a zip file and follow the coding yourself on your own screen and do it by yourself. Okay, without any further ado, let's get into the topic about text data and how to analyze it, what text data is, different ways of approaching it. And I'm also going to give you a quick sneak peek into how I use text data in my work as it's probably not conflict studies in that sense, but still it's international relations, so sufficiently close for that. Okay, so here is, for those of you who cannot open the link in the GitHub in the chat, here is the short link. It's also in the footnote on the following slides, so don't worry if you haven't copy-pasted that one or not fast enough typing that one, you're gonna see it throughout the presentation. Before we get started, a few words about me. I'm currently a PhD candidate at the University of Mannheim. Most of my work focuses on conflict studies, meaning I look at countries that came out of a civil war, and I'm interested in why these countries are stable, meaning peaceful, no civil war at all, or why these countries are unstable, which kind of means the opposite, obviously. So why these countries fall back into civil wars. In my part-time job, kind of, I co-founded and co-edit a data science blog called Method Bytes. It's, I think it's a bit older than a year now. It has been a pretty great adventure because it allowed me to learn a lot about different things I've never ever heard before of. And I think we kind of provide nice tutorials to follow different disciplines, different parts of data science or computational social sciences, if you want. And this talk kind of is based on one of the blog posts that I co-wrote there. So in case you're interested, I put the link at the end of the slides, so you can also read it up at your own pace later. Besides that, I also co-wrote a CRAN package, which is called Overview R, which I think, at least in a comparative research perspective, can be pretty helpful, but I'm also super interested in whether it's generally helpful for other disciplines as well. Because coming from a political science background, as I am, I thought this could be a perfect package for me, but it could also be probably something for someone else. So in case you're using it and you find it helpful, I would love to hear about that. And if not, I would also love to hear about that as well. Okay, so this is for me, this is about what I do, but now what are we doing today? Well, we're talking about text data. And the very big question that you have at first, obviously, is where do you find text data? And I mean, as I wrote it here, it's basically that you find it everywhere. It can be a speech that a politician is holding. It can be a peace agreement that two warring factions are agreeing on. It can be a treaty, it can be a newspaper article, it can be something like a diary report. It can be that people have a survey and they have an open answer option and people write something, they essentially produce text. So all these things are basically text data. And with some of the methods that I'm showing you today, you can tackle these different types of texts. You can automatically analyze them instead of reading them by yourself, and getting an idea of what is going on in that text. And I think, like, because I mean, coming from a social science background, I know where I would use text data, but I was kind of interested whether you would also use it in biology, for instance. And I found one of these research papers that did a somewhat of a meta-analysis using text, like NLP, I think like some 5 years ago or something like that. So you would even find it there, which is probably not even the most obvious place to look for text analysis in science. So now that we know what text data, where we find text data, we probably want to know what text data is. And it comes in really different forms. So it can be a document, as the one that you see here, but it can also be a paragraph within the document, or it can, if you want to zoom in even further, it can also be a sentence, or within the sentence, it can also be the single word. So text data has various different shapes, and it comes in different forms. And this later becomes important when you think of your unit of analysis. For today, we only look at text data as a single word. But I also had another project where I looked at text data in the way of the whole document. But that's kind of the question that you have in mind, the thing that you want to do research on. This is kind of what defines what your text data is. So before we kind of delve into the different approaches that I want to show you, we need to kind of identify some terms and concepts. And the most important one is corpus. And corpus is essentially a collection of documents. So what we're going to have later is I'm going to show you a data set consisting of different speeches at the United Nations. And all these single speeches combine the corpus, so the collection of the speeches. Then on the next level, we do have something called token. That's the word that you saw before. So a token can be an individual word, but it can also be a sentence, a paragraph, or a character. Again, it's kind of, it kind of mimics what I just mentioned before, that this is basically your unit of analysis. And with this token comes another word that is important. It's called tokenization. And I'm going to tell you what that is, because this is essentially the first step that you do when starting with the text analysis. So assuming you have your document, here it's about Leah, who is planning to go for a run on Saturday. With the tokenization, you basically split up the entire text into its single components. So you split it up into its single words, if the token for you is your single word. So here it's Leah is planning to go, and so on and so forth. And then something happens that is important, and that is important to keep in mind. You basically take all these little tokens that you've just created and put it in a bag without any specific order of the words. That's why we call it bag of words. So we do have basically a data set in the end that has all the single words in it, without any specific order, without any specific it kind of refers to your document where it's coming from, but it doesn't really matter whether run comes first or Leah comes first or Saturday comes first or next. So basically this whole tokenization is also called creating the bag of words. And this kind of has a downside, obviously. So probably it's important in some context whether there is something like Leah is not planning to go for a run on Saturday, because then obviously you do have some negation. Leah is not going for that run, whereas here she is going for that run. So it really matters in some contexts where the not probably is placed. And this is like, people are well aware of that downside, but I just wanted to mention it, that you have to have that in mind. But for the moment that we're showing this kind of first approaches, we can neglect that. But once you get deeper into NLP, it really matters at some point, probably rather sooner than later. Okay, so now we have our bag of words with all our little tokens in it. Then the next step that we have to take is, or that we have to do to get our eventual data set that we are able to deal with and that we are able to analyze, we have to do something or create something that is called a document feature matrix. So you do have on the level, you do have the single documents, which here we do have document A, which is the leader is planning to go for a run on Saturday document. And you have document B, which is here in that case about how to make the perfect drink. So two obviously separable documents. You put it on the row level, so document A and document B. And then you do have the tokens that are sometimes also called features on the column level. And here one of these tokens or features that happen or appears in document A is run. So you put it here. And in document B, you probably have drink. So you put drink in the next column. And you can do that with each of these words that are in the both documents or in the single documents. It doesn't really matter. It's just to showcase you what you do next, because now comes kind of the magic of the whole thing. You count the words. So document A is obviously about running. So probably running comes a little bit more often, or appears a little bit more often than one time only in that document. And that's why I put the 4. And document B is about drinking. Well, obviously drink appears a bit more often, so you do have the 5 here. And with this kind of numeric matrix that you generated, you later do all the calculations, all the whatever you want to do. You do all these things. But I'm going to show you how to do that in R a little bit later. And then come like 2 last things that are important. The first one is called stemming. It means basically you get the stem of the word. So we do have here planning, planner, and plans. And I mean, in some sense, it doesn't really matter whether it's the gerund, like whether it's planning, or whether it's the planner, or whether it's plans. So we can reduce it to its like core, to the stem, plan. And then there's something that is a bit of a more advanced stemming in a way. It's called lemmatization, which kind of means that you get the more meaningful stem of the word. So in that case, you do have study, studying, and study. And probably if you just got the stem of these words, it would be stud, which is not really meaningful. Whereas it's actually study in that sense that should be kind of the stem of, or the core of that word. But we're not going to touch upon that here. It's just so that you have heard that, because it's going to be a recurring thing once you go into NLP that you will meet way more often. Okay, so with these like terms and concepts that we have first defined, we can delve into the data that we have. As mentioned before, we're looking at data from speeches at the United Nations General Debate, and they are provided by a research group around Mikhailov. And it was kind of in a way, it was kind of a groundbreaking data set that was published in Political Science, because then people, like, I mean, they kind of did it before, but then people were really able to analyze what state leaders were saying at an international level. And with that data set, I want to show you 2 different broad kind of approaches, one for the known categories and the other one for the unknown categories. And the left one, the one with the known categories, are these supervised approaches. And so here we often have something like a dictionary where people identified that certain words mean something like, let's say, positive or negative. And then you perform something called a sentiment analysis, or you identify topics in the text based on these dictionaries. And for the unknown categories, we don't have these categories at hand. So we just tell the algorithms, in that case with the topic models, for instance, we just tell the algorithm how many topics we probably want to have. And I'm going to show you something called structural topic model today. But I also, like, as I mentioned before, this talk is based on a blog post. There are also more approaches in there that we just cannot cover because the time is like so limited. And it would take obviously way too much time. Okay, so the supervised is on the left-hand side and the unsupervised is on the right-hand side. And the main difference here in that case is for the supervised, we know the categories, and for the unsupervised, we have no idea what could be in there. Okay, are there any questions? Because I think I don't see the chat here. Julia, do you see the chat?
Yes, I can view your eyes on the chat.
Perfect, thank you so much.
But there were no questions. I have a question,
great.
just
Sure.
Not really regarding the analysis yet, but so you were in the United Nations building.
Yeah, I was there last year when traveling was still a thing.
Right. No,
Yeah.
very nice picture. Yeah.
Yeah, it's impressive. You can do guided tours there, actually.
Cool.
Yeah, you should, like, everyone should go there because it's like, it's really like, it's great to see where things are happening and where people are meeting.
Yeah.
Yeah, it's impressive. Yeah. Okay, perfect. So if you do have a question, just post it in the chat. I don't know what the general rules are here, but I'm always happy to jump in and answer questions that you have. Okay, so what we're doing today is we're going to use a program, or a package actually, called quanteda. And quanteda is a short form for quantitative analysis of textual data. So this is what the word means. And it's, as I put it here, a fully featured package that allows you to easily perform NLP tasks. And I mean it in that way, because when I started doing text analysis, I started with TM, which is kind of the base R, at least it feels like that. It's kind of the base R of text analysis. So it works, but for someone who likes things more intuitive, it was sometimes a bit hard to get. And then, like, after starting with TM, I went to quanteda, and it's just like easier, at least, or more intuitive, at least in my way of thinking. There are obviously other alternatives. So there's a tidy text package, which has a brilliant integration into the tidyverse. I'm not sure why I'm not using that one. It's just probably a thing that I'm used to quanteda, and quanteda does a really good job. But for someone who just starts now, tidy text might also be an option. Quanteda is a bit, in my thinking, a bit more intuitive than tidy text at times, because you have, at least when it comes to the pre-processing of the text, you have more options that are easier accessible. But you should also, like, if you just start now, you should also give tidy text a try. And then there is, for instance, also something called corpus, which is, as I put it here, really good if you want to identify certain parts of the speech. So if you want to tag them and label them, but I've never worked with that one. Okay, so quanteda is the way to go. And what do we do, or what do we have to do to use quanteda? Well, there are basically 4 steps, and they're kind of similar when it comes to tidy text as well. You obviously have to import the data because we need it. You have to build the corpus. Remember, the corpus is the collection of all your documents. And then you have to pre-process your data. That's the thing that I just mentioned. And I'm going to tell you in a second what that is. And then in the last step, before we can do the analysis, you can calculate a document feature matrix. And how that works is basically here. Well, obviously, I mean, loading the package, loading the data is kind of obvious, and building the corpus in a way is also really straightforward. It's like just like this corpus command that you wrap around your data set. And then in the next step, I assign a unique identifier to each text, just to have something like a row ID or something like that. It's kind of similar here. And then comes the pre-processing. So the thing that we haven't talked about yet. So with the pre-processing, you have to think about the text in a way that not all words have essentially a meaningful meaning. So if we think about Leah, who is planning to go for a run on Saturday, it's probably not so important that there is a is or an. So she is going for a run on Saturday. So the important things to kind of get the sentence, it's not the punctuation, it's not the hyphens, it's not certain numbers in most of the time. It's not symbols that are in the text, but it's just the pure important words. And that's what we do, like we kind of extract this part of the text during the pre-processing. And we do have one step here, that's where we create the tokens, where we remove the numbers, we remove the punctuation, the symbols. If there are some URLs, like in Twitter data, for instance, we remove them as well. We remove hyphens, but we keep the doc wars, which are the identifiers that we need to identify each document. But we could also have some text that is not really properly cleaned, which is often the case. And it's also the case with our text here, because to generate that text, they relied on OCR. So they basically scanned the text and used OCR to generate the text, like the TXT files, and they are not properly cleaned. So I used this function, or this line of code, or a couple of lines of code here actually, to clean it, and you have to adapt it to each text. So you really, like, before going into the analysis, you have to go into the text and see, or into your data set and see what's going on there.
And then if we can stop just for a
sure.
second, there was a question. How does quanteda handle stop words like and, in, on the? So you say that it would just remove them, right?
Mm-hmm. Exactly. That's what we do here.
Yeah. So and you have the other. Okay, here. Yeah.
Okay. Should I go ahead, or yes. Is there another question?
There was also a question about punctuation, whether it includes also the capital letters.
These are two excellent questions, because these are the things that I'm covering here.
Okay.
So there is something that is inherently in quanteda. So it has all the stop words like and, but, a, whatever, that are in the English language. I think there are a couple of other languages as well, but all my texts are English based, so I don't do any multilingual stuff, which automatically removes all of these stop words if you define it here. And we'll also see in a later example how to manually remove your own stop words, because probably sometimes there are stop words that quanteda cannot capture and you want to remove them yourself. And then we have a function, it's called to lower. This lowers the text, so you get rid of all the capitalization. Again, this could be an issue if, for instance, I don't know, like I was told that if you write God with a capital G, you are more of a religious person, whereas if you write God with a non-capital G, you're less of a religious person. So if you lower words, you might lose some kind of meaning. And this also becomes important if you think of a language like German that is heavily depending on capital letters at the beginning of a word. It might become like an issue once you lower stuff. But in English, it's usually, I would say it's fine. I always do it. And then you also have a function which is called, or an argument actually, it's not a function, which is called stem equals true. And here you stem the words to get the core of your word. Well, and that's basically almost it. You're almost there. You already have a DFM. I called it my DFM here. Your document feature matrix. Remember, like this, the data set that you want to have. You have it here. Then in the last step, I want to show you the DFM first, obviously. So that's how it looks like. You do have your documents here in the first column. And here it's Afghanistan, Angola, Albania, and so on and so forth. And you have your features. And here you perfectly kind of see how stemming worked. For instance, if you look at inform, it probably has been informing or information or something like that before, and it became inform. And then quanteda counts how often inform appears in the document from Afghanistan and how often it appears in the document from Argentina. And you do get, your document feature matrix. One next step that I always do, or that I tend to do, because I don't want to let outliers drive my results, I trim my my DFM. So by trimming, here in that case, I remove all the words that appear less than 7.5% of the time and more than 90% of the time. It kind of depends on what your threshold is. I think this is probably a bit more conservative, but I was whenever I use that, I always use something like that. And it kind of makes sense. It's kind of like looking for outliers in your regression analysis in a way, where you kind of have to make the decision where to set the cutoff or the threshold. Okay. So having done that,
just to make it clear. So when you set the threshold on, for example, 7.5%, this means that it will remove all the words that are used in less than 7.5% of the documents, or in less than 7.5% of all the words that are counted sort of in the.
Oh, that's an excellent question. I think, as far as I know, but I would need to double check that, it's counted less than 7.5% overall.
Yes, of all the words.
I think so, but don't quote me on that. I would need to double check that with the code book or with the manual, what they have written in there. But it's an excellent question. And that's also one thing that you should take into account when doing that, obviously.
Right.
Yeah. Okay, so with having that, we can already start visualizing the text data. And quanteda has a really cool function, which is called word cloud, and you get one of these nice and cool word clouds that you see all over the place. Okay, what I want to do now is I want to show you how the code works in practice. Let me see where my R is. Yeah, here we go. Okay, so this is the R file that I have. I just did the very same thing that I recommended if you want to do it yourself. I downloaded the entire GitHub repository, and in code, you do have a RMD file called code_full, and there you go. We'll start obviously with the preparation. So we'll load all the packages that we need later. If you haven't done that and if you want to follow along, it might take a while because you have to install quanteda and STM and all these things. I heavily commented all the code, so you can always look up things in there. But basically the packages that we're gonna need most are quanteda and STM, which is for the structural topic model. Okay, so once we've done that and we've loaded all these things, we're gonna start with the text data, and I put a short memo for us, or a reminder of the 4 steps that we have to follow. So we have to first import the data, then build the corpus, pre-process the data, and generate the DFM. So in the first step, we load the data with the same code that you have seen. It's the UN_data. It's also in the data folder that you get once you download that. And I can show you that one here. So this is basically how the data looks like. We have a variable with the doc ID, one with the text, where all the text is in, and you see we do have weird symbols in here. You probably want to get rid of the commas here and all these things. We have one variable with the country, one with the UN session where the state leader presented, and one with the year. We can also get another overview of the data here. And what you see is in this column, you have the country and you have the time frame. And I artificially restricted the data to 2000 onwards because it actually goes back until 1975 or something like that. Just to make computation a bit easier and shorter, because where you're going to see the structured topic model is going to take a bit to run. Okay, so what we're going to do in the next step, it's basically the same code that I had on the slides. We're going to build the corpus. And once we run that, we do have an object here. It's called my corpus. And we can have a look at it, but it's not really meaningful. So what we have here, it's a corpus consisting of 3,634 34 documents and 3 doc wars. And it kind of gives you the starting sentence of each of the documents. So it's nothing we can really work with. What we do in the next step, we assign this, this row ID or the text identifier. And we do that with that like line of code. I just copy paste it whenever I start a new project. So yeah, obviously nothing to memorize. And then comes the interesting part. We generate the tokens. And here we do all the things that I showed you before. We remove the numbers, remove the punctuation and all these things. And we get an object which is called token. And this takes a few seconds to run. I just did a like security backup thingy in a way, and I run all these things before because I wasn't sure how much energy it takes up once we start doing the Zoom session. Okay, so what you have here, and you're gonna see that in more detail in a second, you have your documents here, like with the txt file or the txt name, because they were stored that way before. And then you have all the tokens here. And you see it's really like split up into the single tokens. And if they're here for Mr., for instance, if there was a point after Mr., it would have been removed here. And all the commas and everything is removed. But what we still have is we do have capital A's and I's and all these things, and we don't want to have that. So this is one thing that we do after cleaning. So here is this OCR cleaning. This is special for this data set. Again, if you have another data set, you might need to adjust that. But what we do in the next step, and this is the important one, we lower the words with this to lower command. We run that, get our DFM, and now we can have a look at it. So what you have here is exactly what you've seen before. We have the documents here again on the left-hand side, and then you do have the features with all these, like each feature gets its own column, and you do get like the count of the features. Then in the last step, we do the trimming, and now we are ready for the visualization. So one thing that we could do, we could use the mydfm.trim object like that DFM here. I went for the mydfm because by defining the min count and the max words here, we kind of do a trimming ourselves. So I thought this would be redundant, but you could also obviously use the mydfm.trim here. So what we have here is we first load the DFM object. We then define how often each word should a minimum occur so that we don't get only these like really small rare words. And we define the maximum count, like how often each word should maximum occur. And we can add a color palette, whatever you want to have. I went for the Wes Anderson because I like it, but whatever you want to have, you can add it. We run it, and what you get is a word cloud, which is something like, I mean, I like them a lot for visualization, for putting things on the homepage. For instance, we do have a workshop and we always go through the abstracts, generating word clouds. But that's not really for analysis, right? It's just for getting an impression of what is in the data. So you do see nation is one of the top words, develop as well, unit, country, intern, security, world. And the smaller the words get, the less often they occur.
Sorry, what is actually the coloring then?
This
Because
here,
I see, yeah, because I see there is the biggest word is, for example, the nation, right? But some of the smaller words are also colored the same cyan.
No, I think it's a screen issue. So nation has its unique bluish color, and the support, for instance, here it's more of a greenish color.
Oh, okay. Yeah, that's probably just the.
Yeah, I thought I picked a good one, but apparently I didn't. I'm sorry for that.
No.
So the colors here should separate the occurrence of the words qualitative and quantitatively. Yeah. Okay, so let me quickly check. Yeah. I also do have another visualization for you, but you can, I will quickly show you what you have. And you can also go through that yourself because we don't have that much time to go through that in depth. It's basically a lollipop plot to show you the distribution of the top 30 features. And I get the top 30 features here with the top features command from quanteda. I create a data frame that we need for ggplot, and I basically plot it using ggplot. So this is all I do here. And once I run that, I get this plot, which tells me the absolute frequency of the features. You can recalculate it to the relative frequency if you like that a bit better. And you get an impression of what is going on here. So these are all things of kind of exploring what is in your data. Okay, so going back to the talk, the next section are these supervised approaches, because these are probably the things that people are most interested of or about. So I have two approaches. Both are actually dictionary based. So one is what I actually call dictionary based approach, but it's more of a looking what topic is in the text based on a dictionary. And the other one is a sentiment analysis. Okay, we're starting with the topic dictionary-based approach, if you want to call it like that. So if you think of a dictionary, you do have words in there and you do have synonyms in there. These dictionaries are often created by some scientist or someone who is really knowledgeable and who knows all these synonyms. And that's kind of the same with the dictionaries here. So what I have here as an example is defense and trade. Obviously, you would relate some words more to defense and some more for trade. And then you do have your text. And you could read that text, and I think I put the participant screen on my text. So here is on an international level, everyone is better off when using their comparative advantage in trade. Countries to receive money in exchange for goods, something like that. Once I read that as a human being, I obviously know, well, it's about trade. It's not so much about defense or security issues or something like that. It could become something like that, but now it's just trading. And that's actually what the dictionary-based approach does. It kind of counts, or it kind of identifies these words. It counts them and tells me as a user, well, this is actually related to trade. And basically, that's also what I do with the code. I load a dictionary with the dictionary command from quanteda. I apply the dictionary to my DFM, which I do here. And this command then gives me a new DFM, which is here a bit cut, but you're going to see it in a second a bit better. You do get your documents again on the left, or on the first column, which is here at just Afghanistan. And then you do have all the topics. This dictionary comes with a lot of topics on policy issues like macroeconomics, civil rights, healthcare, agriculture. I think they also have weapon or security or something like that. And they count all the words that are in there. And based on that count, they then identify how many words or which one is the most prevalent word in there, or which one is the most prevalent topic in that text, and then they identify the topic. Okay, I'm going to show you how that works now, unless there are any questions. I'm sorry for putting you on the spot, Julia.
No. There were no questions so long, so go ahead with the demo.
Okay, perfect. So I hope the intuition of this dictionary-based approach is really like is straightforward. If not, just let me know. Okay, what we do here is we do have the dictionary. I've downloaded it. Quanteda also has built-in dictionaries, but for the policy agendas, we need a different one. And we load it. And give me a second, just need to move you. So here's an object which tells me it's from the class dictionary, and that's my dictionary that I loaded. It's not really meaningful in that way, but we're gonna use it, or you're gonna see how it works in a second. So what we basically do here, as I said before, we're gonna use that dictionary object down here and generate a new DFM. So actually in a nutshell, like all this text analysis in a way is about generating DFMs, doing something with these DFMs. So what we do, we run that and we have a look at it. And now you're gonna see it a bit better as promised. So you do have the docs on the left-hand side. Here are the countries. And here you see how the topics are distributed across the documents. So what you see is Argentina, for instance, is really heavily about macroeconomics based on the dictionary approach. Whereas, let's say, do we have another one like that? Probably Afghanistan. It's really heavily about, or more or less heavily about education, at least in this first glimpse that we get from the head of the new DFM, because we do have 29 occurrences with the education topic here. So, I mean, in that way, we could glance at the data, we could glance at the DFM. But what I want to do now is I want to get a better idea of what is going on there, and I want to get a better kind of visualization. So what I do in that line of code here, it's basically a bit of data wrangling. So I first convert the DFM that we just generated, it's now called my DFM UN, to a data frame so that I can later work with that. I rename the doc ID to country, because here, this one is later called doc ID. This one is now called country, so that I just needed to have to get a more meaningful, to more meaningfully inspect it later. And I only select a couple of topics that I'm interested in. So let's say I wanted to know something about macroeconomics, international affairs, and defense. So I picked them. I gathered the data to bring it in a different form. And then I generated the relative share of topics, because I wasn't so much into the absolute share, but I wanted to know the relative share. And what we do in the next step with that code here, it's just a ggplot, and it looks a bit wild because it has lots of comments in there, just because I wanted to make sure that you can read it later. But what we do here is we basically just plot it. I'm gonna run it and you're gonna see what we get. So now we do have a distribution of these three topics. Here I removed the countries because it wasn't meaningful to look at it down here, because it was so small and we have 196 or four something countries, so plenty of them. But if you want to go more into that, you can then probably go for region, or to do some separations, do some facet wraps, whatever you want to have to get a more meaningful understanding of what is going on there. But what I just wanted to show you here is how quickly with a dictionary-based approach, you can already get a sense of all these documents. I mean, that's like almost 4,000 speeches that we have at hand, and we already get a glance of that in, I don't know, like 45 minutes or so, which is pretty impressive. I mean, it comes with a downside because you have to trust these approaches, you have to trust the dictionary, you have to make sure that it's a good one, and so on and so forth. But just knowing what power you have on your machine doing that is what kind of impressed me when I did it first. Okay,
Can I have one question? Sure. So there was one question in the chat, and I have another one. Do you have a web page where one can find dictionaries, or perhaps a publication or some? Yeah.
That's a good question. I think I've linked to in the blog post. I'm happy to share that link later. I think Quanteda has 2 built-in dictionaries, but it always depends on what you want to have. And we're getting to that in a second when we talk about sentiment analysis. So this dictionary here is about policy agendas, obviously. But let's say you want to have like positive, negative words, something like that. You would need a different dictionary.
Sure.
And I do have more like sentiment dictionaries in here as well.
Okay, yeah. And one just more short question. So what about the words that are not found in the dictionary? Are they counted somewhere, or because I mean, not all of the words that are in documents will be in the dictionary, I guess.
They just don't show up.
They don't show up, exactly. So you would need to sort of manually check how many are classified. Okay.
Yeah, exactly. So this is also like people tend to believe that once they have these automatic tools at hand, they don't have to do any manual coding anymore. But you have to go into the data. You have to look into the data and you have to see what is going on there to really don't fall into that trap. Yeah, exactly. Okay, so coming from like the topic dictionary approach, we can also do the same thing with sentiment, obviously. It's kind of the same way, right? So you do have a couple of words. I put like 4 down here, like excited, happy, or shocked or sad, which are clearly associated with positive or negative words. And then you do, as I put down here, in a similar way as with the dictionary-based approach, because it's kind of a dictionary-based approach actually, you can identify whether your text is more positive, more negative, more anxious, more whatever you want to put it. And one second. So I do have these 2 sentences here, where the first one, I'm very happy and excited to see you, is obviously more on the positive side. And the next one, but also sad because it will be the last time, a truly sad one, actually. So kind of the algorithm, what it identifies is then the first one is positive, the second one is negative. And it then generates again, the count and the frequency or the relative share. And it tells me, well, this text is more positive or it's more negative. And we do that pretty much similar to the other approach. So we load a dictionary. And we, like here, I selected only column 1 and 2 because it has multiple columns, and you're going to see that in a second. You have different subcategories like anxious, depressive. I don't know, like we're going to see that in a second. I just want to have positive and negative here. So I just select 1 and 2. Let me quickly see. Yeah. So what you get is once you run that and once you check the head of the new DFM that you just generated, you get, instead of the features for the words, you get 2 features called negative and positive, and it gives you the absolute count of positive words and negative words. So that's what we're going to do now. with, 1 second, down here. And here comes the thing that I mentioned earlier. You can also self-define your own stop words. Because obviously when you, like probably some of you have watched one of these speeches at the UN, I did. And it's actually really fun because you can, like, it's so funny how diverse the world is and how diverse people act and behave and do all these things. It's really, it's a bit like traveling. So I did that during the summer a lot for another project. So it really felt like bringing the world to your own living room. So obviously people greet each other, right? So they say goodbye, good morning, and good could probably be be something that is positively connotated, and you don't want to have that. And I just put down a couple of them. There are some word signs that the regex expression earlier didn't identify, and I just listed them here. You can tweak that, adjust that to your own needs. It's basically just a vector of stop words that we generate here. And to do that, we basically do step 4 again. We generate our DFM again. And now what we have here, we do assign 2 stop words. We assign our own stop words that we've defined just now, and we define or assign the stop words that are in English, or the English-based stop words that quanteda has at hand. And the rest of the code is basically pretty much the very same. We just store it in a different DFM object called now my_DFM_sentiment. Okay, so once we have that, we obviously have to trim again the data and just in case to make sure that we don't drive the results by any outliers. And then we can get the sentiment. So what I put down here is basically 4 different dictionaries that you can use. We're going to use the LSD dictionary because it's already built in quanteda and it's easy to load. But there are also other dictionaries, like the most frequently used ones are NRC, Bing, and Affin. And here is like kind of one cautious remark in a way. You always have to double check what the basis of these dictionaries is. So where do they come from? If I remember correctly, for instance, Bing comes from review data. So they scraped lots of Google review or Amazon review data because you do have the stars, right? So you do have already labeled data, plus you do have the words. So it's easy to generate a dictionary based on this huge data set. But probably the Bing dataset is not the best one to use for state leaders' speeches. And there's another one that I really like, which is called, which is based in the sentiment R package, just on a side note. So in case you want to work with that, I think this is kind of the latest standard to use to analyze how different sentiments, because it combines, it combines several dictionaries, and B, it can deal pretty well with negators. So in case you do have something like, it's not good, this is obviously bad, right? But in that case, some of the dictionaries would rather, or probably capture it as good because good is in there. And the sentiment R package can really deal well with these negators, and it has a couple of other advantages that you can look up in the manual, why you probably should use it. But as I said again, for now, we're going to use the LSD, which is like for purpose of showing you how it works, totally fine. Julia, are there any questions?
Yes, actually. One is also that, well, what I was thinking about is Sentiment or any other package or of the one of these dictionaries multi-language?
I don't know, to be honest.
No, okay.
So the
they
thing
are
is,
made
I only
for
do
primarily
it
for
with
English.
yeah. So I cannot say anything about that. The thing is also, when it comes to multilingual text analysis or NLP, it easily becomes tricky, right?
Yeah.
So there's a whole bunch of research on that. I think there's a research group based in Austria that is doing brilliant work on that. So if anyone's interested in that, I can link you to that. But I have never done it. Like, luckily, I was happy to get it all in like one language that is easy to analyze. Yeah. Okay. So what we do is we're gonna use the dictionary here. And as I said before, we're gonna use the first and the second column. Just quickly gonna see whether I can show you that dictionary. Oh, no, I can't. Okay, because it's built in quanteda and you have to access it. I don't know how. So we just like, believe me, column 1 is, I think, negative and column 2 is positive. So this is what we get. Okay, so now we generated the DFM and we're gonna have a look at it. And it's pretty much the thing that we just saw on the slides. In the next step, what we do and what we already did before, we convert the DFM to a data frame to be able to plot it, because like that, it doesn't really tell us that much. What I did actually, for example, for a project that I had with a friend where we used sentiment R in sentiment analysis, we actually ended up using the net sentiment. I think it was the net sentiment. So we generated the share of sentiments and like negative and positive, subtracted it, got the net sentiment of the speech. So is it rather positive or rather negative? And we used then this one variable as the dependent variable in our regression. I think it was the dependent one. Yeah, the dependent variable in our regression to analyze how states behave differently. So these are things that you can then do with that data, just to kind of spark some inspiration, in case you were wondering what you can do with that. Okay, so we convert the DFM to a data frame, which then leads to the data up here. And what you have here, or what you see is, you do have all the negative and positive absolute values in here. Okay. And then in the next step, we do some data wrangling, which basically is some tidy words, some dplyr thingies with mutate, where I generated the relative shares of frequency of the relative shares of the positive and negative frequency. And I also got the country names using the country code package, I think. I know. Sorry, I use string R to get the country names. So anyways, that's what I was doing here. So here we do get the relative share of positive and negative sentiments. And down here, we get the country names. And the U itself also speaks for itself, but we don't want to have the U in there, so I dropped it. And that's what I did here. And we need that because what you're going to see in a second, we want to see how the sentiments are distributed across regions, for instance. And that's what I do here. I basically generated the continent using the country code package. And that's what I do in the first step. In the second step, I got the average sentiment per continent. And in the end, I just plotted it using ggplot. And what you do see here is you do have the average sentiment per continent or by continent for the entire time period. And I mean, obviously what you do see here, you do see this kind of super drastic decrease in here, which is 9/11, obviously. Lots of people were saying like not bad stuff, but sad stuff. So more negative words to give the condolence to the United States. What you can also do is you can also pick single countries and see how the sentiment distributes over time in these countries, just using the sentiment that you just generated. And that's what we do here. So I do generate the country name using, again, the country code package, filter for a couple of countries that I thought would be interesting. And then I plotted plotted it using ggplot again. And I used the facet wrap to get like more meaningful things per country. Once you run that, what you see is the net sentiment by country over the entire time period. And red obviously is negative and green is positive. And you do see, for instance, here in the United Kingdom, some negative sentiments after 9/11, in Germany as well. But also, like in Norway, while it's not really negative, it's less positive during that time. So you do see some trends in the data here that you can like look at it that way. And these are like, I mean, you can also use it, or we used it also to plot it in a map. So you can use static map plots with these sentiments as well. So there are multiple things that you can kind of do with this, with these sentiments that you have or that you just got. But again, whenever you use a dictionary for the sentiments, you really have to pay attention what this dictionary is based on. And review data might not be the best way to identify sentiments of state leaders. Probably it is. I mean, we kind of see the pattern that we were probably expecting, but it could be better. Okay, so if there are no further questions on that, I would go for the unknown categories. Actually, the most important, or not most important, but most interesting part.
No more questions, no. Yeah, and the figures were really pretty, so I'm looking forward to what's next.
Thank you. Well, you do have, like, if you want to replicate them, you do have the code to do them again. And it's like mainly this Wes Anderson palette that makes them so beautiful, I think. But I don't know, yeah, thanks. Okay, so let's go for the unsupervised approaches. So there are a couple of them, actually, and I'm going to show you one of them. In the blog post, I think I discussed 3 of them, but we just won't have the time to go into detail into all of them. Just the main takeaway for unsupervised approaches, it kind of, or at least that's what people tend to criticize about them, it can easily become some kind of tea leaf reading. And you're going to see in a second what I mean with that. And that's why validation becomes even more important to really see what is going on here. So let's go back to our document. This is an example document that I have here. So for the other approaches, we knew which kind of topic we were looking for. So we knew we were looking for macroeconomic topics, we were looking for international security topics, we were looking for trade, something like that. But here with the unsupervised approaches, we don't know that. We just know that we have probably 3 topics or 5 topics or 25 topics or however many topics we want to have. And based on that, the algorithm then kind of detects, or essentially what the algorithm is doing, it kind of identifies the main theme of the topic, or of the document, sorry. It identifies the main theme of the document. And it does so by identifying phrase patterns, word patterns, things that are closer to each other, things that are more distant to each other, like accumulation, clusters of words, all these things. That's how it does it. And there are different approaches how to do it best. There are different algorithms that can be the basic of these topic models. But in a nutshell, all kind of work the same. They do what I did here. They identify a couple of words that are probably topic 1. And they identify a couple of words that are probably topic 2 and do the same with, like here, topic 3. And what we then get is we again get a frequency, or an absolute frequency count of topic 1, 2, and 3. And what we see, obviously, topic 1 is the one that is most prevalent here. So this document is most likely to be about topic 1. Just putting my wording carefully. But it also has components of topic 2 and 3 in it, right? So this is what the algorithm gives you. And you can then use these topics that you got And we're going to see that in a second and explore further whether you have the right numbers of topics, whether you have picked the right number of topics, or whether you should go for more topics, whether they really make a meaningful sense. And oftentimes you really have to involve some human coder or human validator to see what is really going on in these topic models, to really know what there is. So you just cannot use the algorithm and let it run and see what you get out of it, but you really have to pay attention to what is going on there. So there are two kind of main topic models out there. The first one is the one with the unpronounceable name that no one can say. It's LDA. And the second one, and that's the one that I'm going to show you today, is called structural topic models. And it's basically the same as the LDA, and both work in the same pattern as the one that I showed you before. But the structural topic model has one main advantage, besides probably other ones, but one main advantage that I think makes it really nice is you can also take metadata into account. So you can give it more information, which isn't then not really a super unsupervised model, but a semi-informed unsupervised model in a way, to kind of, not really sure if it's like a prior invasion, but probably this is a way of thinking how a structural topic model works. So you kind of inform it with extra information to guide it. Okay, and that's actually the code that we're going to use in a second. So we're going to use the STM package, and that's actually also another advantage of the structural topic model. STM stands for structural topic model, obviously. Installing the package that you need to run the LDA, at least the one that I know and that I used, is really painful. And with the structural topic modeling, it's super easy and it's super straightforward. So another plus for that one. So what you do first is, or what I did here is I assigned the number of topics that I want to have. You usually go for way more than 5 topics with that size of a corpus that you have. Remember, we do have 4,000 documents at hand, but I went for 5 because of time reasons, because what you're going to see, it's going to take a bit more than a minute to run. And what you then again do is you have to convert your DFM, and this time we have to convert it to a structural topic modeling object. We do that again with the convert function. And then in the last step, we run the topic model, and we do that with the STM function. We assign the topics, there's a column called vocab, including the vocabulary. We identify the number of topics that we want to have. And here comes the metadata information that we can feed in. And you can be even more specific. You can add more variables, like in a regression function or formula with a plus, and you can add splines, and you can add whatever you want to have. It's all in the manual. And I put here country in it as an informative. It's not really a prior, but it is an informative metadata. Then we identify the data, and we identify the initialization type. They recommend spectral, and it's actually, I think, also the default. But there are, I think, 2 more options to do so. So at least one of them is also a randomized initialization, which they obviously don't recommend, because then random proportions are assigned to each document, and that's not what you want to have as a starting point. So there's plenty of research, and they link it also in the manual, that recommends that spectral is the most stable approach to go. Okay, having said that, I would then show you how the topic model works, if there are no further questions.
No, just to tell you, because you don't see the chat, everybody's cheering because you have a beautiful presentation, and
Thank you.
and
Thank you. I'm glad that you
that.
like it. Yeah, it's really weird giving a talk on a computer and not really seeing the chat and not really seeing the faces and everything. I'm happy that a few of you had the camera on, because it kind of gives me the atmosphere that I'm talking to people and not to myself. That really helps. Okay, perfect. So let's go with the STM. So we obviously load the package. We assign the topic count. Let's see, I'm gonna just assign it to a different one, because I just, like, as I said before, just to be on the safe side, I ran it to make sure that it works. I know it works, but that it also works when having the zoom on. So we have 5 topics here. We then set a seed. I just tend to do it to have reproducible results. This is actually the zip code of Mannheim, in case anyone is wondering. Just to have like the seed. Then, as I said before, we convert it to the structural topic model object using that function. And as you see, this already took a bit. And I get rid of that. I was playing around with that a bit. So what we have here is pretty much the same code that you just saw before. So we do have the STM function. We load the documents, which are now, wait, I just have to move you a bit. So, which are now in here. So, wait, I thought it would take a while to open. So this is the STM object that we just generated. What you have here is, you do have the documents in here. You have the vocab, which is the vocabulary in there. And you do have a couple of metadata. Like this is the text number, the identifier that we generated previously, year, the session number, and the country name, in case we want to use it. And in fact, we want to use the country name, right? So this is all the things that we need to inform our model. So we load the documents, we define the words in the corpus, we define the number of topics, we use this kind of prevalence that we want to have here, and we use country here. And then we do have the data, or we define where the data is. And it's always in these STM objects, it's always in the meta. And so it's stored in the meta. So you can just load it here. And then we do have this initialization algorithm, which is here the spectral method, however you want to call it. And now we let it run. And this takes a bit. And what you see is it's just calculating all these things. It's going through a couple of steps, and it will probably take like 1 or 2 minutes to converge. If it takes longer, we'll stop and we'll work with the one that I just generated before to see how to proceed. But until then, in case there are any questions, feel free to ask. We do have the time now.
So there is this argument that is called prevalence. But does it really only change the prevalence, or I mean, it would suggest that it puts some weights on the data, right? Or
yeah, it's like this informed metadata that you can add. So you can, like what I did here, I added country to tell it that probably country is an important explanatory factor to identify kind of topics.
Right. Okay.
Like what they have in the manual is, I think they're working with rating data from rating review, whatever. And I think they put a combination with the rating plus, I think, some time variable, the year or something like that. So it could depend on, like we could also add the year here to see whether this makes a difference, and to see whether, let's say, probably after the decolonization wars, which we don't have in our data here, but probably after like 60s and 70s, there was more on African sovereignty than there is now. Whereas 9/11, there's more on anti-terrorism than there was like in, I don't know, like 1998 or something like that. So these are things that help us to inform kind of the topics. And what you already see here is it kind of suggests 5 topics during these steps. And here are again 5 topics, and I think it just converged. It's like, yeah, so the model converged now. And what we can get is we can use the simple plot function. It's basically base our plot and kind of get an idea or a better idea of what the model thinks is in our data. So this is the STM object that we just generated. Just have to call it long because I renamed it. And the type of plot that we want to have is called summary plot. So we just plot it. I mean, I defined the main and the X lab here, but that's pretty self-explanatory. So what we do have here is we have the shared estimation of the topics in the data. So probably I have to make it a bit larger. Not sure if, oops, sorry. Here we go. Hope you can see it. So what they have is, while the topics have numbers, these numbers don't really tell us that much. So what we see is number 1 is down here, number 4 is up here. It's just a random number that the model assigned to the topic. But what is more important are the words that are next to the topic. So topic 4 is apparently about region, council, right. Not really meaningful at first, right? Let's see topic 2, whether it gets better. Here we have global change climate. So it must be something with a climate change. And here it kind of starts this whole tea leaf reading thing. We start looking into topics and it doesn't really feel that much, at least not for me, it doesn't really feel that much like science because we just ran a black box that is doing something and we look at the result and we kind of guess whether it makes sense or not. And that's why this kind of validation and going into the topics is really important. But we could continue, like topic 5 is, at least from the words that we get here, apparently about Africa. Topic 3 is about the war. And with that, we already, we get in, again, trying to be careful with the wording here, we again kind of get an intuition of what is in the text, of what can we get out of the text in a way. And quanteda, or the STM package actually, kind of gives us really helpful insights here. It has a function called find thoughts, and you use your topic model. Again, I have to rename it here, too long. Tell it where to find the texts. It's in our starting data set here under the variable text. And you identify how many documents you want to show or you want to have. And then you identify which kind of topic you're interested in. Just going to make it a bit smaller. Right. So, and what we get here, up here, is we get an extract from one document. You can also set the number much higher, like 2 or 3 or whatever. So you get an extract of the document that is related to topic 4 according to your model. And what we do is, I mean, we kind of get that here. So if we go back, check what topic 4 is, where it wasn't really meaningful, something like region, council, right? We could then continue, go into this example document that we get here and see if it really, if there was a meaningful topic associated to that, see if it really is meaningful and if it really makes sense. And we could probably do that on randomly selecting different examples, checking that. But there are also other packages that help you even better with that, to kind of validate your topic model and to see that you really don't do tea leaf reading, but proper stuff. Okay. Another approach that you could also do, besides looking into the text, is to get a better idea of which features are in the single topic. And we do that with an excellent blog post by Julia Silgi. Never sure how to pronounce her name. But this is basically really heavily based on her blog post and it uses tidy text. So this way you do see that these packages are how do you say that? So you can use them together and you can combine them. As you've seen before, we can convert a quanteda object to an STM object. We can now use an STM object to do it with the tidy text package. So it's not really that once you start using one of these packages, you have to stick to it, but you can really use it interchangeably, and you can use it, you can go from one package to the other one. And that's what we do here. In the first command, we turn our STM object into a tidy data frame so that we can use it. Because otherwise, obviously, we cannot work with it. And what we then do is we group our data by topic. We get the top 10 features based on beta. And there are two, I think there are two parameters that you can use. One is beta and the other one is gamma. Beta gives you, how is it called? The word document proportion, and gamma is giving you the word topic proportion, and gamma is giving you the document topic proportion. So because we're going for the single words here, we're going to use beta. And in the steps in between, we do some wrangling to get a more meaningful data set out of it. And then in the end, we plot it with using ggplot. And that's what we do here. And what we then get out of it is the highest word probabilities for each topic. So we get more than just 3 words out of it. And we can see more, if you want, you can also get not only the top 10, but the top 20 or whatever. But here we get the top 10 words. And what you see here is topic 1, for instance. It's not only right, govern, and whatever the other one was, but it's way more. It's republic, democracy, democrat, something like that. So it kind of starts making more sense that this probably belongs to one topic. Same here with topic 3, which was also right, one, and war. Not that meaningful, but now that we have terror and Palestinian terrorists and all these things in there, it's probably about the Israel-Palestinian conflict, which again makes more sense, right? But we're still in the kind of, at least that's how I feel when I do that, in the sphere of reading tea leaves. So it's kind of a validation method in a way that we're getting here a better sense of the things. We're still not there that we really have a deep feeling of feeling confident about what is going on here. Another way of kind of, and then this is kind of the thing that I feel you have to do with the topic models, you have to look at it from various different angles and various different perspectives. So another way what you can do with the topic models is also to do something that is called a perspective plot. And it means that you put 2 topics into the perspective. And that's what we're doing here. So if you remember the base R function that we used before with the summary plot, we do that here again, but now it's called perspectives instead of summary. And what it basically does, it puts topic 4 and 5 word-wise into perspective and tells us where it's closely or not so closely related. So again, it's just a kind of static insight into these things. And they're actually more packages out there that really help you to do that. And one of them, or actually 2 of them, that guide you to a Shiny app that is really helpful is first the STM Insights package, and the other one is the LDA Viz package that help you in that sense. And I'm going to show you the LDA Viz package in a second. There's also another one that's called Oolong, coming from this tea leaf reading approach. As far as I know, it's not based on a Shiny app, but this one is based on 2 or 3 or however many you want to have manual reviewers of your topic. So it kind of helps you to extract the topics and parts of the topics and then feeds in the feedback from the reviewers on the topic and then calculates whether it's a good match or not. So in case you're interested in these things, have a look at them. I think this is actually like the way to go, and that's what you read all over when you go into topic modeling. Okay, having said that, what we're gonna do is we're gonna use LDA-vis. And it basically, like STM comes with a function called toLDA-vis, which converts our topic model that we just generated into a LDA-vis topic file, document, object, whatever, and opens a Shiny app that shows us more information or gives us more information about the topic. And that's what we're going to do here. So, oops, give me a second. It's been moving itself without me telling it anything. So what we're getting here is, I have to move you again a bit. Okay, I'm putting you up here. So what we get here is basically we do have a two-dimensional, it's a two-dimensional map that shows us how this evaluation package thinks the topics are connected. And what I really like about that package is that once you hover over a topic, you get an idea of, if I were there in person, I would point at it because I cannot move my cursor without making it go away, but you can see it. So it shows you on the right-hand side the number of words and the frequency of the words, how they appear. And it puts a another red bar on top of it to show you kind of the share of these words in the topic. And you can do the same for each of these things. And the larger the circle gets, obviously, the more prevalent the topic is in the document or in the documents. So that's what you have here. And this kind of, I mean, I do like Shiny apps a lot because I think they are really intuitive in kind of getting an idea of what is going on in like kind of more complex things. And that's also what you can see here and what you can do here. But that's, again, I mean, only one kind of a guiding help to understand the topic models. I think the kind of main way of really dealing with it is doing it manually with some coding assistance or like review assistance or whatsoever to really get an idea of what is going on there. So this is kind of the downside or the bad news about topic models. You have to use something like Oolong, like that package or something to get a more meaningful understanding of the thing. Yeah. Okay, so this is all about that, or that I have about topic models. There are a couple of other cool functions in the STM package, which is, for instance, which I put here, it's called Search K, which helps you to identify whether you have enough Ks, like whether the number of topics is meaningful or not, whether you should add more topics. Generally, at least as far as I know, if there's something popping up like really weird words together that shouldn't be together or non-meaningful words together, you should probably think of adding more Ks. And obviously, 5 topics for a data or a corpus that we have consisting of 4,000 documents is not enough. So we should go bigger actually and go with more topics than just these few. Okay, so this is what I have about topic models. Are there any questions on that? Or any other questions on anything that I touched before? Brought you 2 examples because when I was preparing that talk, I was like, okay, so what else can I give you as a kind of takeaway of NLP or text analysis in general? And how, like, what can you do with these things? And I actually never thought of that much before without the scope of my own research. I mean, so what I could do with NLP in my research, for instance, would be to analyze peace agreements or to generate a new data set, for instance. So when we think about like our observational data, or for instance, also the observational data that we have in conflict studies, it's often based on newspaper reports that tell us something about kind of a number of fatalities or some kind of violent incidences that are happening across the globe. So we could use NLP in that sense to generate these data sets. We could use NLP to, as I did it with a colleague of mine, to analyze whether there are any whether there are any positive or negative sentiments toward a specific state or not. So we could use it in various different ways, right? But I mean, like one thing, and that this kind of it's not surprising actually when you think of it, but it is in a way, you always have NLP in your life. And I brought you 2 little examples where you have it and where you basically can also do it yourself with just actually these little and pretty simple steps that I showed you, because they all follow the very same logic. So what I have here is that's something that I did with a friend of mine for a hackathon. It's actually it's also kind of scientific, but it's a search engine that we built, and we did that with a word2vec and doc2vec. I don't know if it's called algorithm, but anyway, so what we did there is we used NLP to identify abstracts and scientific articles that are relatively similar and dissimilar on this 2-dimensional space. We identified that, and we generated the Shiny app to plot them and to make them accessible. Or actually, we used the Shiny app template that was already available, but we put it in the Shiny app. I don't want to take credits for that. And we put it in that template and made it available for other people to look things up. And it was actually like, it just took us a weekend. It's not super sophisticated, but it went relatively quickly to do that. And the kind of story that I want to deliver with that is basically, it's not complicated. It's really simple. It's really straightforward. And it's pretty much the similar steps that we have seen before, how you can build something like that. And if you think, for instance, I mean, Google obviously has super sophisticated algorithms. But if you think of something like another search engine that you can think of, it basically uses similar ideas as the ones that we have just seen. And then the other thing, it's in Python, just because it was easier to deploy it, but that's a chatbot. And there are multiple of really, really, really cool examples out there, how you can build one your own by yourself on your own. And I just did that within it wasn't even 10 minutes. And I'm not bragging about that, but it's just simple. And it's not the best chatbot actually, but it works in a simple way. It has its disadvantages, but if you spend more time on that, you get an even better one. And it's actually one of these fun exercises where you also meet NLP, where people kind of use it to, I don't know, detect the best insurance for you or something like that. You do have the apps all over the place where you can use them, scan stuff, and they tell you, hey, go for that one and don't go for that one. So kind of the main takeaway with that one is NLP is everywhere, even where you don't expect it. And having this kind of knowledge at hand really helps you to enter the world of NLP, also beyond academic research, but also within. And there's so much data out there that we haven't yet discovered and that we haven't yet found to do cool stuff with. Yeah, so this is kind of the closing remarks for the talk, kind of. I didn't plan it to be that that much in favor for NLP, but here are a couple of resources that I've listed that I thought could be helpful for you in case you want to delve into that. So I would just quickly walk you through them. So here you have a bit on quanteda. Quanteda actually comes with so many great tutorials. And if you want to have something, or if you want to know more on that, here's a link behind that. You can just click on it They also have a cheat sheet, as every good R package. Then there's the blog post that I mentioned earlier. It's the first one here. There's also a seminal paper on using automatic content analysis. That's what they called it back in 2000, I don't know, 13 probably. So this is really readable. I would recommend that like really highly to read that. And then there's a textbook out there that is online that is also really, really nice. And then when it comes to sentiment analysis, there's obviously sentiment R that I mentioned before. Then there's the paper that I mentioned before. It's in a collection, but I think it should be accessible in case you're interested. And there are more resources like cheat sheets on regular expressions, because if they're not yet your best friend, they're going to become your best friend in a bit once you start working with that. And there is something on model validation like the long package and STM insights that I mentioned before. That's actually it for the talk. Here's again the short link for the slides and everything in case you're interested. I'm happy for any questions that are out there, if there are any. Yeah, thank you actually for listening and bearing 2 hours, almost 2 hours with me talking about NLP.
Yeah, amazing. Yeah, how time flies. I mean, this is 2 hours, but you've done such a nice job presenting it and sharing all the tips and code that I didn't notice that it was already 2 hours. No, it's very useful, and I see that everybody writes here. Oh, thank you, super nice, wonderful, amazing. All the positive.
Perfect.
I see only the positive. So I don't know whether anybody has any questions. Then they can just unmute themselves.